All right, I am ready to take what we've learned about the idea of inheritance and try implementing that in Java by extending our first class. Now, I am going to assume that you understand the basic idea of inheritance and what it is, and you can watch the video that is an introduction to inheritance if you haven't done that yet. In this video, with code that we write, we're going to build on one of the examples from that video, and we're going to implement a bank account class and a couple of subclasses based on that. Now, we're going to not do the entire class diagram. We're not going to implement everything that we used in that other video, but just enough to show you the idea. So let's go ahead and jump over to VS Code and start working on our class. And to demonstrate extending a class, I've got a couple of files that I'm going to work with here, and you can download these out of Canvas. I've got first a very simple implementation of that bank account class from the graphic there. And it is, like I said, very straightforward. It's got some fields, it's got some getters for those fields, a couple of setters, and then it has a deposit method and a withdraw method. And about the only thing interesting with these two that you might not expect is that the withdraw method has some logic in it to just make sure there's enough money before it does the subtraction. So it checks to see if they have enough money, and then if it does, it reduces the balance, and then it's going to return a Boolean. It's going to return a true or false, indicating whether or not the withdrawal was successful. I also have a test program for that, and it's not a comprehensive test. It doesn't check everything in the bank account class, but it instantiates an object. It puts in 500 bucks. Now it's going to try to withdraw 700 and output an appropriate message, whether or not that succeeds. And then because I know that's really not going to succeed, there's not enough money, I also then try withdrawing $150 with, again, a message outputting whether or not that is successful. And finally, I'm going to output the balance at the end just to make sure that that worked. So let's go ahead and run this. All right, so it does fail to take out $700, but then it successfully withdraws 150, and when I check the balance, it leaves us with $350. The first thing I'm going to need to do is I'm going to make a new Java file. And the convention in Java generally is every time we have a new class, we make a new file. I know that we don't necessarily have to do it that way, but I'm going to stick with the convention. And the first subclass I'm going to create is going to be a checking account. So I'm going to call this CheckingAccount.java. And Visual Studio Code is going to help me out by putting in that class statement. And in order to implement this idea of inheritance, the keyword in Java is extends. So we're going to extend the checking account class, or sorry, the checking account class is going to extend the bank account class. I started to say that backwards. If we were talking about this, we would say that we extend the bank account to a checking account. But we're in checking account, so we are that is going to extend bank account. And in fact, let's just stop there and try that and see what how this works. Back in my test program here, I'm going to comment out a bunch of that stuff so that I don't get confused by it, but I might want it later. And I'm going to create a checking account object. So checking account, I'll call this checking1 equals new checking account. And now I'm going to just try depositing some money into that. I'll put in $150.76. And now I'm going to print out the balance. And let's just run that. Even though I haven't really written any code, let's just see what happens. Okay, always hard to see it in the output window here, but that does work correctly. Let's go ahead and clean up my workspace here a little bit. And the idea here is literally all I've done is add that keyword extends and indicated what class I am extending. So the rule that we say is that we use the is a test, right? A checking account is a bank account. And so I can use it just like a bank account. In other words, it gets to inherit all of the term we use is all of the members all of the variables and methods and anything else that is part of that bank account class automatically gets inherited by checking account. So without even writing any additional code, I'm able to use that checking account. Now let's start extending the functionality of that bank account into what a checking account can do and what it keeps track of. So I'll start with some of my fields here, my instance variables. And the idea here is I don't need to indicate things like balance and the owner's name because we've already inherited that. All I have to add in this class is stuff that is specific to a checking account. So what we keep track of with the checking account is I'm going to have an integer for the last check number. In other words, what's the most recent check that we've written. And we'll also keep track of how many checks we have remaining. This isn't, by the way, the most realistic or possibly useful checking account class, but I'm just trying to keep the examples really simple. And it's going to be easy to use integers that we can just add one to or subtract one from, that kind of thing. And in order to, since these are these variables are private, in order to do anything with them, I am going to need a couple of getter methods for that. So public int get last check num, and that's just going to return this dot last check num, and then same kind of thing for checks remaining. And I'll clean that up. And with that new functionality in place, let's go over to our test program and give that a shot. So now I've got the ability to also get the last check number. So number equals, or checks from last check number. Okay. Now, as you're probably going to guess here, the last check number is going to be 0 because we haven't set that to anything. But that demonstrates that this is indeed working. Now, just to make this clear, and I hope it kind of already is, but if we come back up to here to our, we've got this bank account instance called account one. I can't get a last check number from account one because that's not a checking account, that's a bank account. So the idea is we're extending a bank account into a checking account and we're adding some stuff. That stuff doesn't apply to a bank account. I think that's kind of implied, or I hope it is, but I always like to make that clear. Not because you won't understand it, but because when you're writing code, that's an easy thing to get confused about is, wait a second, am I using a bank account here or a checking account here? So the things that we add to a subclass are not available to the superclass. Let me go ahead and fix that, get us back to where it's working. So we want to add some methods to our checking account as well, not just these fields that we've added. So let's go back to that account and take a look at what we got. And the first method we want to add is going to be a method for writing a check. And this is going to be what I would call a modifier method because it's going to modify one or more pieces of data within our class, so modifier methods. And this is going to be public. And for now, we're going to say that writing a check doesn't return a true or false. At the time you write a check, we don't have any way of checking what the balance is and knowing if it's valid or not. It might overdraw, it might bounce, right? So we're going to write a check. And for our purposes here, we're going to say that we need to specify the amount of the check and what the check number is. As I mentioned, this is not the most realistic checking account approximation here because we're not going to keep track of who the check is to or what the date was or anything like that. I'm guessing it doesn't matter because probably a lot of the people watching this video have never written a check in their life because you do everything online now. But it's still a good analogy, I hope, for this inheritance idea. And the first thing we're going to do is we're going to update the last check number variable here, because if we have written a check, then now the last check number is going to be equal to whatever check number we've passed in here, this integer that's a parameter. So that updates that. The other thing we need to update, of course, is the balance. And so we can say this dot balance minus equals amount. And we've run into an error. Okay, the problem is Visual Studio Code doesn't know what balance is. And here's why. When I created my bank account class, I very correctly specified balance to be private because we always make our instance variables private. Um, but that causes a problem. Private means that no other class can access it. Well, checking account is another class and it kind of needs access to that variable. So we have a few different ways we can address this. We have one way of addressing this that we absolutely should not do, and then we have a couple options that are okay. And so let's start with the one we should not do. And one that I see students do every semester is they come over to the bank account class and, oh, this is easy enough. I'll just make that public. This is particularly popular with Python programmers because in Python, you don't run into this kind of restriction. Python just lets you do whatever you want. And I come back over here and, hey, great, it works. This is all good. It's not all good because object-oriented programmers' heads just exploded. Remember, we never let anyone touch our privates. These variables are private for a reason. We want them to be protected. We want them to be uh, made safe from people messing around with them. And the reason here is that if somebody shouldn't just be able to come along and manipulate the balance. That's the whole reason we have these methods in this class. If you want to change the balance, you make a deposit or you make a withdrawal, and that's how you change how much money is there. You can't just come along and change that variable. But in checking account, when we write a check, that does change this variable. So again, there are a couple different ways we can address this. And one of them is to go into our bank account. And up until now, we've only had public or private, but there is another access modifier we can use in Java. It's called protected. So private doesn't give access to anybody, any class. Public gives access to every other class. Protected is in the middle. And what I wish I was about to tell you was that the protected keyword gives access to any subclass of bank account, but that's not quite how it works. And in fact, I mess up sometimes when I explain this, and I explain it that way. In Java, the protected keyword gives package level access. So it gives access to any class within this package. And so it's not quite as good as I would like it to be, but I always have to say that carefully because I'm used to kind of saying, well, that gives access to the subclasses. It gives access to more than that, unfortunately. But this is an appropriate way to solve that problem. Okay, in object-oriented programming, making an instance variable protected so that subclasses can access it is the way to go. All right, and let's go ahead and test this. Let's go over to our test accounts, and so we've made a deposit. Let's say check one dot write check. I'm going to say write a check for $50, and it's going to be check number 13. And so when I run this now, we should see that we have deposited 150. We've now written a check for $50, and it's check 13. And so the balance is $100, and then that crazy floating point math there that gives us that obnoxious decimal afterwards. And then we've got the check number is 13. I'm not going to bother rounding that off because this is not the point of the video. We're just learning about inheritance. But this seems to be working now. Let's go back over to our checking account. I did say that there is another way to do this, and that is that we can use the methods provided in our superclass if those help us out. And what I mean by that is that when we write a check, we are kind of making a withdrawal, right? There's some other stuff associated with it, like a check number, but ultimately this line of code here where we're subtracting the amount, that's a withdrawal. So what I can do is I can just use that method from the superclass. So I can say this, because this is an instance method, this dot withdraw amount. And so now when I run this code that writes a check, It's going to bounce into this checking account method. It's going to update the last check number. And now it's going to call the withdraw method. And you have to understand how these method calls work in Java. And I'm going to explain this in kind of layman's terms here. When we have a method call in Java, it's going to first look within the current class. It's going to have a look around and say, hey, I need to call a withdraw method. And if it has one, then it runs it. If it doesn't have one, it moves up the inheritance tree or up the inheritance hierarchy, and it goes to the superclass. And it says, oh, okay, a checking account extends bank account. So let's go look there. And it goes into bank account and it says, hey, I'm looking for a withdraw method. Do you have one? Yep, we have one right here. And it runs it. If I try and call a method that's not in either of these, so let's say I call this dot takeout amount, then it looks around here and says, well, I don't see a takeout method in checking account. So it goes up and says, well, that extends bank account. So let's check there. Hey, do you have a takeout method? No, we don't have a takeout method. And it gives us an error. It won't compile because it can't find an implementation of that. We're going to learn a little later that there's a little more to it than that because there's one more check that it does. It checks the object class to see if there's an implementation there, but there's not. So that line of code doesn't work. This approach of using the superclass method has a couple of advantages. One of them that I like because I'm nerdy about object-oriented programming and encapsulation is that now I can go back and make this private again, right? Because I don't need to access the variable directly. I can call the modifier method that is intended to edit that for us so that I'm still protecting, maybe the wrong word to use since I just got rid of the protected keyword. I'm still keeping that variable safe. I'm still keeping it encapsulated. So I like that aspect of it. But the other aspect that I like is that if I have code written in this superclass method, I don't need to duplicate that now because this superclass withdraw method doesn't just subtract the balance like I was doing. It also checks to make sure that you're able to do that. So I don't want to have to rewrite all of that code. And you can imagine, well, what if this also does some other stuff? Maybe it goes into a database and it updates some stuff there, or it goes to a website and it checks things, it pulls the balance out of that website. I don't want to have to maintain all that code. I don't want to have that code duplicated. So if I can just call that method, then that makes it easier for me to maintain my code and to make sure that I'm following all the rules that withdrawing money requires. Now, a couple things to keep in mind just about the basic idea of inheritance. So, bank account is my superclass and checking account is my subclass. I can still make other subclasses of bank account, right? So I can make the other example in my previous video was a savings account. Okay, so I can make a savings account .java, and I can say that that extends bank account. And this is going to have, stuff that a savings account has. So it might have private double interest rate, okay, and then it might have a method that is private void add interest or calculate interest or something like that. And I won't actually implement that on this video. But the idea is now I can have multiple subclasses of the bank account class. And in my test program, I can make a savings account in exactly the same way. Now this, I'm not going to be able to demonstrate anything with it since I didn't really write any code for it, but it's going to have, just like when we started the video, this is going to have access to deposit and to get the balance and all of that stuff that comes with the bank account class. So it's not a one-time deal. I can make as many subclasses of bank account. I can make, another way of saying that is I can make as many different types of bank accounts as I need. And often we do have many different Subclasses, in fact, one of the very common things we do just as a design approach is that we make, bank account might not even be really an account that we really use. It's just sort of a base class that we use to put all of the code that checking accounts and saving accounts have. And we never actually use a bank account. So all of that is perfectly fine. So this really is just the basics of how we use inheritance. We've learned how to use the extends keyword to create a subclass, and we've added some fields and methods, and we've kind of demonstrated how that works in our test program. With all of that as a foundation, we can now start learning some other inheritance concepts, and we'll do those in separate videos. In the meantime, you can reach out if you have any questions.